My name is Miriam Gawida. I am a technical PM on the Windows security team, particularly working on the authentication space. And I am joined here by Steve Seifus, who is the dev lead in this space. And we're here to talk about our strategy in eliminating NTLM in Windows. The session is focused on key areas in Windows authentication, which is famously known as NTLM on Kerberos. Those are the two protocols that we'll be focusing on today. We'll go through all things NTLM, why it's so insecure and yet still used, and then we'll move into Kerberos and all the magic that will be happening over the next couple of years. So starting with NTLM. What is NTLM? NTLM goes back and predates Windows 2000. It is a protocol that authenticates using a challenge response mechanism, and it is typically used when Kerberos is not available. NTLM does not provide any robust server verification authentication, and it relies heavily on legacy crypto. And that is why it is broadly categorized as susceptible to relay and replay attacks. Operationally, it persists because it's simple, legacy, and in some deployments, the only option available for authentication. So let's translate that into wire level flow and show exactly where the security properties break down. In this flow here, we go through an NTLM-based authentication. In this example, a client is trying to access a resource, so it connects to the server, and the server asks who you are, and it provides it with a challenge. The client then provides a string with username and password, plus the response to the challenge, and the server gives access. Simple, straightforward. So what's the issue? Problem number one is that there is no server client verification. When the client is connecting to the server, it doesn't actually know that it is connecting to the intended server. So an attacker can intercept the request and act as it is the server. Problem number two is the super weak and old crypto that is being used. As you can see, the message that the client sends back to the server uses an antivor-derived anti-hash and HMAC MD5 to compute the challenge response during the authentication. And then lastly, problem number three, because of this lack of mutual authentication and the use of the outdated crypto, an attacker can relay the challenge response to another server without cracking the password. Combined with weak legacy hashing, which is the MD4, and their usable NT hashes, this makes NTLM highly susceptible to relay and pass the hash attacks. Now that we know that how insecure NTLM is, let's look into where it's currently most used. We currently see a lot of NTLM usage in workgroup scenarios where Kerberos authentication is not feasible due to its reliance on domain-based accounts, and that forces the system to fall back to NTLM. Another common scenario is when the client lacks line of sight to a domain controller. And then lastly, when authentication requests are made either using an IP address instead of an SPN, and Kerberos doesn't currently recognize IP addresses, or when the SPN provided during authentication doesn't actually map to any known service in the domain controller. Those are the scenarios where we see Kerberos being attempted and then falling back to NTLM. So now let's go through how you can identify NTLM usage in your environment. Late last year, we released the enhanced NTLM auditing to Windows 11 24H2 and Windows Server 2025. These supersede the old policies that were made available a while back. And because NTLM remains embedded in Windows, and especially in those workgroup and legacy environments, with the enhanced auditing, you can dig deeper into what or who is still using NTLM, why it is using it, and where the access requests are coming from or going to. In this screenshot here, there are two examples. There's event 4020, which is audited from a client, and event 4023, which is audited from the server. Event 4020 shows that NTLM v2 was used. It also shows you the process name, which is SSPI auth, and the reason that NTLM was used. It was directly called by the calling application. And then a few other details that would be helpful. In event 4023, though, the main red flag here is that NTLM v1 is being used, but then there's also a lot of missing information under NTLM security section where things like target machine and service binding are not found. So this could signal for potentially suspicious activity that would require additional investigation. You can find more about this auditing and all the information that is available using the link that's on this slide. So now that we've talked about NTLM and how to identify its usage in your environment, I'll pass this over to Steve to talk about Kerberos, which is our more advanced authentication protocol in Windows.
Thanks, Miriam. So let's talk Kerberos. It is better security. One of the questions that we end up having to ask ourselves is, if we don't have NTLM present, how do we solve some of the problems that NTLM itself is itself solving? So the first thing that we want to do is we want to take NTLM and we want to make it more secure. And then on top of that, we need to make whatever we're migrating to work in those scenarios where NTLM can only be used, such as scenarios where line of sight is required to a domain controller, or where you're using a local account on a machine that is not domain joined. So the first thing that we're doing is solving for security. And the way that we do that is we move NTLM to Kerberos. This is a long-standing goal that we've had for a great many years, going back to when Windows first introduced Kerberos back in Server 2000. And the goal is that with Kerberos, we get some of those key security properties that NTLM lacks, such as server authentication, the ability to prove that the service that you're trying to communicate to is actually the service that you want to talk to. And that has downstream effects for preventing relay and replay attacks. The second thing is, from a cryptographic perspective, Kerberos has properties that allow us to be more agile in how we approach which cryptographic operations we use, which algorithms we use. It allows us to get towards a more post-quantum capable security level. And also it allows us to rely on different credential types other than just passwords. NTLM has the unique property that it requires a password, whereas with Kerberos, it can use a smart card, it can use FIDO, it can use any number of things that the protocol supports. So our first goal is moving NTLM to Kerberos. So the scenarios where NTLM gets used, we move to Kerberos. So as we move NTLM to Kerberos, we need to solve for the problems that Kerberos already has that NTLM doesn't. As I mentioned previously, NTLM has the behavior where it doesn't require a line of sight, which means that when I'm connecting to an application, the only thing that needs a line of sight to a domain controller is the application itself, the service that you are accessing. Whereas with Kerberos, the client also needs line of sight to a domain controller. And so if you have a network infrastructure that blocks you, say you're on a VPN, or you have a complicated networking environment and you cannot get to a domain controller, Kerberos cannot be used, whereas NTLM can, because the service or application that you're connecting to has line of sight. So that's thing one. We have to solve for that. The second thing is that in environments where you don't have a domain, or you have an account that isn't a member of domain, such as a local user or a consumer account that is not part of a domain, what do we do about that when a machine is connecting to another machine? Historically, this used NTLM because that's what the machine understood. There's no central authority that Kerberos requires in order to do that. So how do we solve for that? The two things that we need to solve for: no line of sight and local accounts. What do we do about that? Well, we have two technologies. We have IAKerb and local KDC. IAKerb is this idea that networking does not define the path that the client has to take to get to a domain controller. We move the authentication up to the application level stack. So what happens is, normally in a Kerberos world, the client will contact a domain controller and ask the domain controller, can you please give me a ticket to this service? And then once there, the client then sends that ticket to the service and gets access. With IAKerb, we're flipping it on its head, and we're asking, when the client cannot talk to the domain controller, we're asking the application, hey, I have a message for you. Can you forward this to the domain controller on my behalf? And that allows for scenarios where we have segmentation of the network. If you are on a VPN you're trying to access, or you are in a highly constrained environment where you just don't have access to a domain controller, what you do is you ask the application, please forward this on my behalf. And that solves all of our networking issues. Our line of sight goes away. As long as the application has line of sight, you're good. And then there's that second problem, which is what happens when you have an application that requires an account that is local to the client or local to the machine, and it doesn't have a central authority like Active Directory or Entra. What do you do about that? Well, In the Kerberos world, the thing that does the authentication, the thing that issues the ticket is the KDC, the key distribution center, or in our case, the domain controller. Well, we asked ourselves, what if we turn every machine that has a local account into its own KDC, its own local KDC? As a result, what happens is normally when you're doing NTLM to authenticate to a client because you're using a local account, what we're actually doing is we're kicking off Kerberos and we're saying, hey, other machine with this local account, can you issue a ticket for this credential that I have local to your machine? Turns out, yes, you can. And in order to harden that so that we are not introducing extra networking overhead for the properties that Kerberos requires, such as requiring line of sight to a domain controller, which in this case is the machine itself, we just use IAKerb to transport that over the application. That way there's no new ports. You're not changing anything within the application itself. It is all transparent to what the application is doing, and the client and server agree through IAKerb that it's doing Kerberos. What does this actually look like? In principle, we're not going to go through what Kerberos actually does on the wire because that's a very, very long and complicated process. But what you can see here is that there's a bunch of messages that normally in a Kerberos world have to go to the domain controller first. If we're looking at the messages on the wire, we have our ASREC and our TGSREC. All of those things normally have to go to a KDC or a domain controller first, but instead, what we're actually doing is we're saying, hey, proxy server, your application server, whether that's your SMB server or your mail server, whatever ends up having the operations that you need your application to do, those instead are forwarding to the domain controller on your behalf. So the client asks the IAKerb proxy, hey, can you please forward this message to the domain controller? We do this back and forth until we get what we call the AP rec, which is your proof that you are who you say you are. And then that is handed off to the application in question and says, hey, here you go. Here's your application or your AP rec. Please authenticate me. And away you go. It's very simple in how that works. So the second case that we have is where we're looking at the local KDC, which is when we have a workgroup account, a local account to that machine, or a consumer account where there's no central authority that proves you are who you say you are. It's actually pretty simple. The client uses IAKerb to communicate to the FAR server. And instead of the FAR server going off and talking to a domain controller, it just asks the local service within Windows itself. We call it the SAM, the Security Account Manager. That contains verification of your account information. It contains your password verifiers. It contains all of your account information. And the local KDC just sits on top of that. So the client over IAKerb connects to the target server. The target server does Kerberos to its local KDC, which connects to the SAM database. The SAM database checks all of the accounts, issues a Kerberos ticket for your application, returns it to the client, and then the client has your ticket so it can put it in its local cache and be able to replay it as necessary for future authentications. And then it sends it back to the server when it's ready to actually use it for accessing, say, your file share, your RDP, whatever is the local account that you're using for. So as a result, NTLM is completely taken out of the picture. There is no way to authenticate to a server using NTLM, or no need to use NTLM, because we're able to prove that we're doing Kerberos to that machine. So let's actually show this off. So first things first, we're going to do something very simple. We're going to try and connect to a SMB demo share because that's what we end up doing. And what we're actually saying is, while you're doing that, please drop NTLM. Do not allow us to do that. And the problem with that is that means that we have to do Kerberos. So we've done Kerberos, and what we can see here is, as you look at the network trace on the far side, we see Kerb error, KDC pre-auth required. That's saying, please do your password. So, okay, so we do this response back and forth, back and forth, back and forth. And then we get to the point where we have the tree connect, which says this is how SMB works in order to get access to your file share. So as we dig into the message, what you can see is we have our OID, espinago simple. That's just internal mechanisms for how all of this works. But the very first thing we say is, by the way, let's do IAKerb. And IAKerb is there to say, okay, we're indicating to the far side, we're able to agree on doing IAKerb as opposed to doing NTLM or Kerberos. So the next step, which is this session setup, we are going back and forth and we're sending those Kerberos messages. And so when you take a look at that negotiate token, is you step through them, you'll see one of them is your AS rep. One of them's your response. One of them is your TGS rec to say, hey, can I have a ticket to the SMB server? And then finally, you end up with your ticket in the end. And then we're back. So next, when are we doing this? What's coming up? When is this going to be available? And IAKerb's coming and local KDC is coming. Our goal is to have this out soon. With IAKerb, that means that you have full protocol support between supported clients and servers. That solves all of your networking and routing issues. And then with local KDC, we are getting that out for things like target for cluster deployments where machines are doing local accounts if you're a consumer account or if you are an unjoined machine. This works well for small business deployments, for isolated machines that aren't domain joined. And if you're doing things like remote desktop for different environments like domain join, if you're using something like Labs as an example, all of that ends up using local KDC. So I'll hand this back to Miriam to talk about our next steps in disabling NTLM.
All right, perfect. So now that we know what all is happening behind the curtains and all the work that we are doing, we also publicly shared some of the timelines just last month. We published a blog that goes through our plan for default NTLM disablement in Windows. And this is a screenshot of what our roadmap is going to look like. So in the second half of this year of 2026, you can expect to see IAKerb, local KDC, and also upgrading hard-coded to negotiate. What that is we've identified first-party apps in Windows that are hard-coded to use NTLM and are working on implementing negotiate in their authentication flows. By the next version of Windows Server and Client, we are planning to have NTLM disabled by default in most cases. So those cases include all the scenarios that we mentioned all the way at the beginning, which are unknown SPN, IP address, local accounts. And then we'll also be introducing new NTLM blocking policies that can help you block NTLM where you see it. So what can you do now? To prepare for the default disablement, we highly suggest that you start leveraging the enhanced NTLM auditing that we released last year. This will help you again understand where NTLM is being used in your environment. You can also try to follow the publicly available guidance on blocking NTLM or disabling NTLM and upgrading to Kerberos wherever possible. You can also join our private preview group to test IAKerb and local KDC before it GAs. And that's it. These are just some useful links that you can use to learn more about the things that we've covered here and go more in depth, and more ways that you can start preparing for the default disablement of NTLM in Windows. Thank you for listening into this session. We hope that it was both interesting and informative, and we hope you enjoy the rest of your Tech Takeoff sessions. Thank you.